Good day to you. This is Galactic bringing you another presentation in a series in basic axiomatic science. This would be mathematics, but it's also geometry. These two subjects are closely allied, more closely than was fully recognized by previous generations. Currently, we're attempting to get the primary units. This would be the line and point and circle and sphere, just to name 4 objects with which we must deal intimately. These are primary objects in comparison with such things as triangles, squares, cubes, polytopes, polygons, polyhedra. These are composite objects of simpler objects in the subject of geometry, which has a direct bearing on number systems. We need to discuss that a little more carefully to be sure we know what we're talking about. We discovered that we cannot begin with a point, and Euclid overreached himself, although he was following a formalism which he made popular for 2,500 years. That's a pretty good record. So there's no criticism here of Euclid's technique. He was consistent in what he was trying to do, but he only dealt with the straight line. And that's in fact where we now know we get our number system is from the straight line. They're one and the same thing. What I basically want to add to the mix, not saying that I discovered this fact, but simply bringing it to everyone's attention so we're all on the same page. The line has one operator called add. And that's where my research diverges from that of all of science. Because as far as I can tell, nobody has ever made the next statement that I am forced to make, which is that our number system is one of 2 complete number systems. But it's hierarchical because we had to begin with linear numbers. Linear numbers differ from another kind of number, but you have to begin with linear numbers. We have done so. Euclid essentially began the process, which was completed in my lifetime, of getting a full understanding of the number system used in all of science and all of humanity. We've ever and always had one number system until the advent of the complex number system, with which I've dealt fully in prior presentations. That is a 2-component number system which revolutionized mathematics to the point that mathematics at upper echelon physics exclusively uses complexity. And this extends away from 2D complexity, which we call it's a 2-component number system. We call it the complex number system for that reason. Although there's a footnote to that, there's an additional complexity beyond simply having a 2-component number. As you know, a complex number has 2 components. But one of them is a non-numeric component based on the square root of -1, which has a definite geometric and mathematical connotation, which has proved incredibly useful in physics. That's why the complex number system has taken the place of all other number systems. This is not a criticism, a critique, or making fun of. The complex numbers are miraculous. That's why they're used exclusively. The fundamental theorem of algebra, sometimes called the fundamental law, the fundamental proposition, or the fundamental this or that, the fundamental expression of algebra is based on a notion of complex numbers, which is a 2-component number. Why do I bring that up and emphasize it? Besides the fact that science has, is that a 2-component number system is one of the keys to understanding numbers at all. So the complex numbers are valuable for a reason. They have been extended to 3D in the quaternion system, which is an extended complex number system having a 3-component number system instead of a 2-component number system. You cannot have a 1-component complex number system because it's no longer complex. Complexity refers to higher dimensionality of numbers. What we have always used in science is the simplest form of a 2-component number. And you may recognize it. It does not exist in the additive system. It's not an expression of linear mathematics, is this other relationship. It's not based on the line. It's not linear. And it has to do with multiplication. It also has to do with division. And these are the other 2 operators besides add. As you know, we traditionally add subtraction to make a list of 4 operators, but you can see that logically there are 2 operators that come in pairs. The additive operator only works on the line. It is associated with the line. The object called the line only has 1 operator. What we have discovered at long last after centuries of probing our number system, I was able to at least uncover the fact, although I'm not sure I'm the first, I can't be absolutely sure of that, but I think I'm the first to notice that our fractional numbers are very special numbers. And we use fractional numbers all the time. Light speed is a fractional number. Space-time is phrased as a fractional number, but it's expressed in Einstein's 4D geometry, not a 2D geometry, as would be for complex numbers. But Albert Einstein's formulation of space-time is a hypercomplex system. It's extended to hyperspace. And those are the actual names. I'm not making that up. This is not science fiction. So that's where we're at. Using dimensionality in terms of linearity to make 4-line systems. In the case of hypercomplexity, this is used in relativistic mathematics, which extends down to the quantum level now, in the effort to extend space-time geometry into the quantum world. That has not been fully successful because it's no more effective than regular numbers at getting at the quantum paradoxical system. So that it's not been able to be solved with mathematics. Therefore, we suspect that perhaps the mathematics is incorrect. That would be necessarily true, and that is true, and you should accept that. The reason for the quantum paradox is our mathematical system. So the simplest way to approach this interesting discovery is to notice how the universe actually draws geometric objects. It does not draw triangles. It does not draw squares. It does not use a grid. It doesn't use the straight line. I will repeat one last time as we proceed, just to introduce this, that the linear number system is embedded in spherical number space, which is the proportional number system space we call fractions. These are special fractions that always have a 1. A fraction has 2 components, just like a complex number, but it's a simple number, not complex. That's called a fraction. One of the numbers has to be 1. The reason one of the numbers has to be 1 is that sets up a special series of fractional numbers. And this turns out to be the quantum number system for circular space. This extends directly to spherical space and therefore is the correct geometry for the correct number system. That has been proved to exist. It's simple. We were staring at it the whole time. So the fractional number system always has a 1 in it in our system. This is a subset of what are called the fractions in modern mathematics. Both components in a fraction in modern mathematics can be real numbers. That's absolutely wrong. It's okay for linear algebra. You actually have to do that. That's why we have calculus, is for those linear conversions, because we cannot address circular space with linear numbers directly. It always leads to irrationality. It always leads to losing part of your number, and therefore it's useless for real space. We need to be absolutely precise in the geometry we apply to the universe. We now need curvature, we need the circle, and we need the sphere. Nobody has penetrated this, but it's simple. You begin not with a line, but you have to begin with a line, and we've already done so, and I'm capable of stating that that's been completed. So you should accept that, because that is what I discovered. One of the aspects of my discovery is that the linear number system is embedded in spherical number space. What is spherical number space? It's proportional number space. What's that? The fractions we just defined. The fractions that all have 1 in them. Now the 1 can be in the numerator or denominator. The reason for using 1 is it's the multiplicative identity. The same reason that we use 0 on the line, we use 1 in proportional space, and that's the correct number. That's the correct name for the number system. It's one of 2 names because it's both a geometry and a mathematics. Just as our linear number system is both a geometric object called the line, and that's identical with the number system. The sphere has a number system that's identical with the sphere. Exactly proportionally to our linear number system is identical with the line. That may not have been grammatically stated in the best way, but I think you got the point. This is an exact parallelism. This is an exact analogy. On the number system we currently use, that can be composed into a fractional number system that's closed, consistent, and complete in proportional space, which you now know is multiplicative division space. Division is the fraction. Multiplication is the inverse of division, and therefore the number is composed on 4 component numbers, 2 fractions that are reciprocal. Each number, that is, each component of the spherical number, is a fraction. 1 fraction has 1 in the denominator. That would be the whole number linear equivalent. For instance, 2 is 2 over 1. The reciprocal of 2 over 1 is 1 over 2. That establishes the wavelength frequency relationship for quantum space in spherical numeric space and spherical geometric space. It uses a 2-component fraction system to compose the spherical space, exactly the same way as our single-component linear numbers are used to compose a grid. We have now a spherical grid. This is called polar coordinates in spherical space, and this is the simplest form of mathematics. It's the simplest form of geometry. Everything we know about the line, especially and peculiarly from Euclid in the sense of his excellent formulation of linear geometry, that is embedded. And it's fully recoverable the same way that linear numbers are recoverable from complex numbers. Linear numbers are recoverable from spherical numbers. And this now time to switch. We are going to be using spheric numbers henceforward. I have proved that this is exactly equivalent to using linear mathematics. That's a major discovery, and I hope you appreciate it. We now need to go on and see how it applies in physics. When you begin with spherical space, I very often will call this circular space. Consider them synonymous. They virtually are. And we'll get to that again. But for now, the sphere has the center number of the number system. Remember, on the line has to have a center number. It's the Archimedean balance point of the geometric object called the line. It has an Archimedean balance point on the 2 polar infinities. That makes 0 a kind of infinity. It's one form of the linear infinity called the infinitesimal of linear space. That is called 0, and that is assigned the number 0. That is the linear center point of universal space. That is not adequate because it's orthogonalized, and that does not capture the true geometry of physics. That cannot describe the atom. That cannot describe gravity. And it certainly cannot describe space-time accurately. It's accurate enough for solar system spaceflight. You might think that's infinitely accurate. We've got it. Incorrect. It's infinitely inaccurate, and it is incorrect. And space-time is the derived formulation of the correct formula for gravity. And the correct formula for the atom will not be fully understandable as long as we continue to use the numbers we're using without developing them into their natural form. The natural form of numbers in the universe is not the linear number system, but it's based on it. And in fact, this is the magic of the whole system of numbers that the universe uses, that it has a two-tier number system, and we've only been using the lower tier. We've been using the derivative number system with respect to the integral number system. And the reason we have irrational numbers and the division by zero error is due to having not based our mathematics on the correct foundation. And mathematics itself must be extended now. It's a set change. It's not an actual change to the mathematical system, but it's a recognition of a structure that nobody has ever recognized until now, which is that the sphere contains the linear number system entirely. The entire system of linear mathematics is contained in another number system. And the interesting thing about how we compose the numbers for each system is very simply stated that for the line you use a one-component number, but for the sphere you use a two-component number system whose components are linear numbers. And that is absolutely correct and absolutely profound. And here's why. We now can see space in two ways. The linear number system gives us a grid, and space-time is a grid. We can change that. It doesn't actually destroy anything. In fact, we need both forms of vision. We're equipped with linear vision. We're also equipped with spherical vision. Obviously, that's a later evolutionary step. That's later in the evolution of numbers, the evolution of the human mind, the evolution of the mathematical system we were given by the universe. This is evolution. This is true evolution. That the number system we're using is the training wheels. And it was validated by the universe because otherwise we would not have technology at all. Technology is solely due to linear algebra. That's the reason we have cell phones, computers, space travel, and just simple electric lighting, electricity. We harnessed electricity with linear algebra. We are now concentrating not on anything on Earth, we're concentrating on the universe. It's just been a curious misperception, this lasted a century now, that when we discovered the universe and we discovered the atom, and the universe, the atom and the universe were discovered almost simultaneously. It can be dated to the 1920s in both cases. You can go a little earlier or later, however you do it, but it's the first half of the 20th century. We discovered the center of everything. We completed the journey of the Greeks in finding the atom. We have discovered everything there is to discover in subatomic physics, atomic physics, and it all makes sense in molecular physics as well. We got that part of it. What we also discovered was the universe, and it's spherical. Again, two spheres were discovered in the 20th century. The sphere at the center of everything, and the sphere at the edge of everything. And they're both spheres, and yet we continue to use linear numbers. So obviously that's the problem. It is the problem. But we can't lose linear numbers. They're the computable numbers. And that's 0, 1. That's linear. Is binary machine logic is linear. That's the whole value of linear numbers, is that it emulates linear logic. You can make it into electronics. You can make circuits using 0, 1 machine logic. Well, that's not spherical. That's linear. That's why we're addicted to linear numbers, is because they work. What nobody has noticed, even after the advent of complex numbers, which is a two-component number system, nobody ever realized that we're already using two-component numbers. Our linear numbers are one-component numbers. That's why you can add them. But two-component numbers can be multiplied. Two-component numbers express division and multiplication. Only two-component numbers can express division. And if you set it up the way the universe teaches us to do so, you don't have division by 0, because there is no 0. That confuses us. It confuses us for an obvious reason. There has to be a 0, or there could not be linear separation to make distance in space. If you want to have distance in space, then you have a 0. That's why it works. Where it breaks is when you add time. Time is not linear. That's the key difference, and that's what I wanted to tell you, to introduce the mathematics that proves that and solves it, so that we can actually see time. We must now. Albert Einstein taught us that we have to see time. See it? You can't see time. Well, you have to. You have to see time. You know why? It's real. And so you have to define it. You can't with linear numbers. You can't with linear algebra. You can't with lines. Because time only occurs on a circle. Time only occurs on a circle. I hope you understand the profundity of that. It has a mathematical significance because that circle is closed. So is the number 1. 0 is not a closed number. It's not a quantum number. It's a pseudo-quantum number. It's a derivative of the quantum numbers, which are the linear numbers, which are the points, which are the particles, which are the quanta. We don't want that aspect because you're seeing everything as if it were a particle, a quantum, a point, and a one-component number. Those 4 things are the same thing, and none of them match reality. Your numbers don't match reality. Your line doesn't match reality. Your particle does not match reality. That's the quantum paradox, is that your particle is ill-defined. We never got particle right, which means we're not using numbers right. It's all bound together in the same concept. The reason why we have a quantum paradox is that we have a quantum, and the quantum is not linear. That baffles the shit out of us. The quantum is not linear. It's not susceptible to linear analysis. It's only susceptible to circular analysis. And for that, you need the exact geometry that corresponds to the linear grid. I discovered that. The spherical space that's composed by proportional unit numbers is exactly equivalent to the integration of cubic space and hypercubic space. To get hypercubic space, you have to extend spheric space. In order to get hypercubic space, that's the Einstein solution, that's spacetime. Spacetime is hypercubic. It cannot be hypercubic if you want to solve for gravity and the atom and the universe, or anything else that's spherical. There are several other candidates. The electron, the proton, and the photon are all spheres. So you must switch number systems now. You have no choice. because otherwise you're going to miss out on the other dimension. You cannot see the other dimension when you use lines. The other dimension is exactly what the line is not. It's what's left out in linear space and cannot be recovered even with calculus, even with the complex numbers. You cannot get back the function of the circle. It cannot be done. Sine and cosine do not do it. Calculus doesn't do it. Quaternions don't do it. Matrix multiplication does not do it. You can't do it with I. You can't do it with anything linear. You have to switch to the proportional number system because that's the definition of the circle. The line has a definition. It's called linear numbers. The circle has a definition. It's called proportional numbers. You must learn that now. It does not use the additive identity for obvious reasons. It uses the multiplicative identity. That's 1. That's the closed number. 1 is the closure number. That's the definition of the circle. And that is the correct unit circle. The unit circle we use is misnamed. It's not the unit circle. And the unit sphere, that's not the unit sphere, that's misnamed. That's not the unit sphere. The unit sphere would have a value of 1. The pseudo-unit sphere, or the linear unit sphere, the linear unit sphere is the correct name for the unit sphere. But the correct name for the unit sphere is 1. That's the definition of the sphere. It is the number 1. From that you can construct complex space without complexity. You do it by splitting infinity into its infinitesimal and integral. And so you have integral infinity, which is lazy 8 over 1, except the lazy 8 is spherical lazy 8. It's the lazy 8, but it's not the same as linear infinity. Linear infinities are infinite. Spherical infinity, there's just one. There is just one spheric infinity. It's split because everything in spheric space is split with respect to linear numbers. The linear numbers are fully recoverable. And in the next lecture, I'll show you why. We're coming up on a half an hour. Let's summarize what we learned. There's only one point in spheric space, right? But you know that it's actually a pole. The line has two poles in opposite directions in linear space. The sphere has two poles in opposite directions in spherical space. So the center pole is much different from the edge pole. Are they so different? They're not different except in one respect. The operator. The operator. When you have a sphere with a value of 1, the fractional numbers that have 1 on top go in. To the proportion that the numbers, that is, the component numbers, have 1 on the bottom, those are whole linear numbers. Those make space. The inverse fractional numbers make time. And we'll be discussing that in incredible detail so that you will be ahead of the game in physics because you'll have the answer that nobody else can possibly ever get. You will get it with spherical numbers, the proportional numbers that the universe uses. This is Anagalactic bringing you the secret of mathematics and physics. This automatically solves the quantum paradox, as I've discussed many times in the past. I get better and better at doing this every time because this is a discovery vector into a new age of science. This will change our mathematical practices. This will change our interpretation of the theories that currently are doing nothing for science except guiding it into one dead-end brick wall cul-de-sac after the other. Nobody's been able to solve the quantum paradox. You will.